Remember that question I asked before about the mass of the Earth? So, why do you think we use scientific notation? There are definitely many numbers in science that are very large or very small that would be hard to represent in standard notation. So if we use scientific notation, then it makes it easier, shorter to write those. You don't want to write like 20 decimal places. So the scientific notation is a way to write those numbers in a quicker, more concise way. So a positive number is written in scientific notation if it's written as the product of a real number, a, where a is between 1 and 10, so it could be equals to 1, but there's no equals to, so it's got to be less than 10, which means somewhere between 1 and 9. And an integer power r, the exponent of 10. So scientific notation will look like a times 10 to the r, where a is a number between 1 and 10, and r is the exponent, which tells you the number of place values. So let's write these numbers in scientific notation. 4,700. So where's the decimal here? After the ones place. So that means that our base, or a here, that we're talking about for scientific notation is right now is 4,700. If I move this way, it's 470. If I move this way again, it's 47. I'm getting closer. If I move this way again, it's 4. 4 is between 1 and 9, so I'm going to stop there at 4.7. And you can put the 00, but the zeros after the decimal are non-significant. So 4.7 times 10. Then I just need to know how many places did I move that decimal. That's 1, 2, 3. And it's a positive number because the number that we're supposed to have in standard notation is larger than the number that we have here. So when we expand, we're going to go to the right to make that 4,700. Our next example, 0.00047. So the decimal is right here. That means right now, a is 0. I need that to be a bigger number, so I'm going to move this way. It's still 0. It's still 0 before the decimal, and still 0. Now it's 4. I can stop. So 4 decimal 7, and we move the decimal place 1, 2, 3, 4 times. This time we're going to make this negative because we're going to move the decimal to the left to go back to the standard form, which means this is a negative exponent. The other way around, if we're going to change from scientific notation to standard notation, we move the decimal point the same number of spaces as the exponent on 10. If the exponent is positive, you move to the right. If the exponent is negative, you move to the left. So our example here, 5.2738 times 10 to the third. It's a positive, so we're going to move to the right 3 decimal places, 1, 2, 3. So that becomes 5273.8. This is the standard notation of that number. It is no longer being multiplied by 10 to a power. Our next example, we've got 6.45 times 10 to the negative 5. That means we're going to move the decimal to the left 5 times. So 1, 2, 3, 4, 5. And put the decimal there. So anywhere where we don't have a digit in the place, we have to add a 0. So we're going to add a 0 for all of those places, making that point 4 zeros, 6, 4, 5. This is the standard notation of this number. It's no longer being multiplied by 10 to a power.